This unit is all about functions. And so before we start a functions unit, we want to know what is a function and how does it behave. So that's what this video is about. All right. A function is a rule. It's something that tells us what to do. Most of the time in this class, we're going to talk about it in terms of mathematical functions. So say I had this squaring function. The function is x squared. The idea is you have a number that you put in, an input, all right? So I'm going to put 3 into the function, okay? This 3 is called my input. And then once I do whatever the function tells me to do, I get an output. So in this case, if I put 3 in, and I do what it tells me to do, which is I'm going to square anything that I put in, then my output becomes 9. And we write functions as pairs of inputs and outputs. So I could say that when I input 3, I get an output of 9. This is one way to write it, as a coordinate pair. Oops, you have to spell it right though. Coordinate pair. And then the other way to write it is as an input-output pair in function notation. So I input 3 into my function f, and I get out 9. My input always goes in here, and my output is always what the function equals. All right, so a coordinate pair, these are 2 ways of saying the same thing. All right. Let's look at some notation. The most common way to write a function is f of x, all right? But if I have 2 functions in the same problem, I might call one of them f of x and one of them g of x. You could use any letter, h of x, r of x, q of x, whatever you want. Sometimes the letter means a little bit more. So if I'm looking at this square and I say it has a side of x, and I want an area function, well, I might name that function a of x, where a stands for area. All right, and then I could say, well, what is the area of my square if the side length is 4? Well, the area function of a square is to take one side times the other side, or to square the side, right? So the area when my side length is 4 is going to be 4 squared, which is 16. Well, what if instead of a side length of 4, I have a side length of 3/4, 3/4? Well, I would take 3/4 as my input now. I would put it into this area function. Say 3/4 squared. Remember, you square the top, square the bottom, and you come out with 9/16. Okay, so depending on what your input is, that's going to determine your output. Now, a function works because you know that whatever you put in is going to give you something unique out. All right, my favorite example of a real-world function is a vending machine. If I want M&Ms and I go to a vending machine and I see that M&Ms are behind the button G5, all right, then G5 better give me M&Ms. I don't know how to do that little and thing. Is that the M&Ms sign? Let's pretend it is. All right, G5 better give me M&Ms. All right, if I hit G5 and it gives me, potato chips, I didn't want potato chips. Vending machines only work because when I press G5, only one thing is going to come out. Okay. Similarly, if you have a television, channel 3, if channel 3 goes to NBC, then every time I hit 3, I would expect to get to NBC. It would be weird if I hit channel 3 one day and instead of going to NBC, it took me to ESPN. That's not what I'm trying to watch, all right? TVs work because you know the number of the channel is going to lead to the station that you want, okay? Alternatively, something that is not a function is a jackpot, all right? Every time I pull this lever, on a like one of those casino game things, all right, I'm gonna get a different output. All right, one time I'm gonna pull the lever and I might get, smiley face. That's my smiley face. It's beautiful, I know. Star 7, and then the next time I pull the lever, I might get 7 star 7. I don't know what I'm gonna get out, but it's something different every time. So a jackpot, one of those, I'm calling it a jackpot machine, is not a function because I'm doing the same input and getting a different output every time, okay? So mathematically, if I am looking for something that is a function or is not a function, I am looking for every input to have a unique output. All right, so in this first example, 3 goes to -1, 0 goes to 0, -3 goes to 0, and -6 goes to 2. Every input is leading to only one number. It is okay to share a number, right? As long as I know that 0 goes to 0 every time, it's okay that -3 also goes to 0 every time. So this is a function. And it's a function because every output goes to every input goes to exactly one output. Okay? If you were looking at this second one, do you see how 4 sometimes goes to 5 and sometimes goes to -5? Well, that's like saying channel 4 goes to NBC and ESPN. You can't have one channel go to two different things, okay? So in this picture, it's the 4 that ruins it in this mapping, all right? 4 goes to two different things. So we say this is not a function. You can be sad about that. Put a little frowny face. Oh, it's not a function. All right. So we can also tell when something is a function based on its graph. So if I'm looking at relationship A, if I'm saying I have a relationship that's built around a set of points, all right? If I'm looking at 3 on the x-axis, does 3 have one output or two outputs? Well, an output is represented by a point on the graph. If I input 3 on the x-axis, I have an output right here at positive 1, 2, 3, 4 at 4, and I have an output right here at -4. All right, so we're saying an input of 3 goes to 4 and to -4. Well, you're not allowed to go to two different things. You're not allowed to have two different y values for the same x value. Okay, so we would say that relationship A is not a function. It's a graph, it's just not a function. Okay, and the way you can tell is that these points line up vertically. On the line x equals 3, there are 2 points that fall on that line, and that's not allowed. If you have 2 points on a vertical line, then you are going to two different outputs for the same input, all right? And you might remember this as the vertical line test. All right. If you look at relationship B, you can see that no matter which x value I choose, there's only one point on the function for that x value. All right, so if I choose 1, I'm only going to -2. There's nowhere else that I can go. All right, the only output is -2. If I choose 2, the only output is -3. Okay, the other way we could say that is it passes the vertical line test. No matter where I draw a vertical line on relationship B, right, it's only going to hit one point on my graph. So we say that relationship B is a function. Yay. We're happy about that. Functions behave. We like when things behave. So you can tell if something is a function by saying if you give an input, are you going to have more than one output? All right, or by using the vertical line test. So for part A here, if I say this is my input, does it have more than one output? Does it fail the vertical line test? It does. See how there's 2 outputs here for my input of -3? So it's not a function. All right. And you could say there are 2 outputs for one input. That's the reason. There are 2 outputs for one input. Okay. For B, no matter where I go, all right, every input goes to one output. So this one is a function. Every input has a unique output. All right, and looking at C, similarly, Yes, it is a function. I'm looking at my vertical line test here. There's no place where I have one input that goes to two outputs. So we'd say, yes, it is a function, and it has the same reason as that. Every input has a unique output. All right, so we can evaluate functions. This value, or this letter right here, like f, tells you which function to go to. So if I'm finding f of -4, this is saying go to the f function, which is right here. All right, and input -4. So you would have -2 times -4 plus 5. And when you do that math out, you get 8 plus 5, which is 13. Okay. This second one right here, g of -4, says go to the g function and input -4. So when I do that, I'm going to g now, and I'm saying -3/4 times -4 minus 2. Well, 3/4 of 4 is 3, so this is 3 minus 2, which is -1. Okay, so we could say that for this f of -4, when I input -4, I get out 13. For g of -4, when I input -4, I get out -1. Okay, these are my input-output pairs written as coordinate pairs. Now for this one, this g function, I'm giving you the output, so we have to be careful. You're not putting it into the function. You're saying that that's the output of the function. So you're saying 7 is the same as g of x. So I will let g of x equal 7. So 7 equals -3 over 4x minus 2. So you add 2, you get 9 equals -3/4 x. And if I multiply both sides by -4/3 by the reciprocal, then I get 9 divided by 3 is 3. So I get -12 equals x. Okay, so that means that if my output for g of x is 7, my input has to be -12. So I would write that pair like -12, 7. That's my coordinate pair right there.